So the next time you look up at the sky, remember, it is not silent. Somewhere out there in the pitch-black depths of space, the universe hums its eternal tune, a song of creation, destruction, and infinite possibility. A song we are only just beginning to understand. And maybe, just maybe, the cosmos is waiting for us to learn how to join in the melody. Hello and welcome to the Mystery Channel, where in each video we discuss strange and profound topics, revealing secrets that science is still unable to fully explain. Out there, beyond the stars, in the vast and unfathomable expanse of the cosmos, there is a sound. Or rather, there is something that behaves like a sound, a symphony woven not with instruments, but with gravity, light, and time itself. It has no orchestra and no sheet music, yet its existence humbles even the most advanced minds on Earth. It is called the Cosmic Symphony, a poetic name for a scientific enigma. But what is it? And how can there be music in a void, a vacuum where sound as we know it cannot travel? Let's dive into this mystery, uncovering clues scattered across the universe and chasing the rhythm of the ultimate celestial melody. Human beings are creatures of patterns. From ancient priests deciphering the movement of stars to modern physicists analyzing waves of data, we are inexorably drawn to rhythms in the cosmos. For millennia, we've looked up at the sky and seen only silence, a cold, empty void. But in the 20th century, with the advent of advanced telescopes and groundbreaking physics, scientists made a discovery that transformed how we view the so-called vacuum of space. The silence is only an illusion. In the 1960s, a group of researchers working at Bell Laboratories stumbled upon a faint, persistent hum coming from every direction in the night sky. Frustrated at first, they thought it was interference in their equipment, a tone that refused to go away no matter which way they pointed their instruments. But eventually they realized there was no escaping it. The hum wasn't coming from their machinery, it wasn't even from Earth. It was coming from the universe itself. This haunting discovery became known as the Cosmic Microwave Background Radiation, or CMB. The lingering afterglow of the Big Bang, stretching across the universe like an ancient song that refuses to fade. To the ears of a scientist, the CMB is music, cacophonous noise billions of years old, a relic from the formation of the cosmos. And like a melody passed through time, it contains clues to the structure of everything we see today, from stars to galaxies to our very bodies. But the CMB was only the beginning. What came next would further shatter our understanding of the cosmic void. Fast forward several decades. Using instruments and observations far more sensitive than ever before, astronomers found that the universe isn't just painted with light and radiation. It also vibrates, it hums, it resonates. Take, for example, gravitational waves. Predicted by Albert Einstein in his theory of general relativity, these waves are ripples in the fabric of space-time itself, triggered by cosmic collisions on unimaginable scales. Picture two black holes spiraling toward one another, colliding in a cataclysmic embrace. When this happens, they don't just merge. They send waves outward for billions of light years, like the echoes of giants clashing in a faraway void. In 2015, the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, detected these waves for the first time. And though the frequencies were far too low for human ears, scientists realized they could convert the ripples into audio data, effectively hearing the sound of the universe moving. It was low and unearthly, a cosmic whoop, a fleeting note from an eternal scale. Suddenly, more than ever before, the idea of a cosmic symphony didn't seem so far-fetched. But the mystery deepened when researchers discovered that these interactions represented just one layer of the universe's musical structure. And so the pursuit began, a search for other waves, other notes hidden within the dark regions of the cosmos. What they found stunned even the most seasoned astronomers. Take the phenomenon called the chorus. Not metaphorical this time, but literal. Certain planets, including Earth, emit electromagnetic waves that ripple out from their magnetospheres. When these waves are converted into sound frequencies, what emerges is eerily beautiful, like the singing of choirs in the void. NASA captured some of these sounds, a near-mythical audio rendering of Earth's magnetosphere protecting us from solar storms. The result? a rich melodic tone that seems almost conscious, as if the planet itself is vocalizing. Jupiter, Saturn, and even the Sun produce their own songs, unique vibrations that weave together into a grander pattern. It isn't sound in the traditional sense, it's energy made audible, yet listening to it reminds us of the interconnected symphony all around us. But of course, the greatest mystery lies not in the relatively local choruses of our solar system, but in the distant orchestra of galaxies and clusters. What if the very structure of the universe, the way galaxies are distributed like threads in a cosmic web, has its own rhythm? Astronomers studying the large-scale structure of the cosmos began to notice patterns in the distribution of matter. And as they modeled these movements, they found something astonishing, a kind of pulse. It's quiet but consistent, like the beating of some incomprehensible heart within a multiverse of activity. One prominent theory suggests that this rhythm may have originated within the first few moments of the Big Bang. During those chaotic, primordial milliseconds, sound waves, yes, literal pressure waves, traveled through the hot plasma of the early universe. While those sound waves could never escape into the vacuum of space, their imprint remains encoded in how matter is arranged today. And as galaxies cluster and expand, they echo this ancient music, playing it forward in slow, almost imperceptible rhythms. But there's one final frontier to this cosmic concert, a component so mysterious it feels more like science fiction than fact. Dark matter and dark energy, the two unseen forces that make up most of the universe, have their own gravitational effects. Scientists speculate that they, too, may contribute their own notes to the Cosmic Symphony. But these notes are beyond anything human senses or even our most sophisticated instruments can yet perceive. Perhaps these hidden forces are playing on scales too vast or subtle for our understanding. Perhaps they form the baseline, the foundational hum of the cosmos, keeping time for all the brilliant bursts of energy and matter above it. And if dark matter and energy are playing a tune, who's listening? Who can hear something so vast and otherworldly? Perhaps we've always been listening. At its heart, the mystery of the Cosmic Symphony comes down to something both profound and humble, the human need for connection. At its heart, the mystery of the Cosmic Symphony comes down to something both profound and humble, the human need for connection. In sound, in light, in vibration, we strive to find meaning, to decipher our place in something so much larger than ourselves. When scientists listen to the universe, they aren't just deciphering data, they're awakening something deeper. Something that connects us across time, across space, across the silence of the void. So the next time you look up at the sky, remember, it is not silent. Somewhere out there in the pitch-black depths of space, the universe hums its eternal tune. A song of creation, destruction, and infinite possibility. A song we are only just beginning to understand. And maybe, just maybe, the cosmos is waiting for us to learn how to join in the melody. So if you enjoyed this video and are interested in mysterious phenomena and mysterious historical incidents, don't forget to like, share, subscribe for more incredible and unbelievable stories. And leave us a comment with your opinion on this topic. See you in the next video. Thanks for watching.